Okay, so this is the last page of the kinematics homework. So finish these two questions and we will check the answer.
A few moments later.
Okay, so this question is actually quite similar, very similar to the example that we did. So let's just take a look again. So the first thing that you want to do is to define the direction. So let's say downward is positive, and so the initial speed is actually u equals to -8 instead, and we know a is 10 meter per second square, and then the s will simply be positive 35. Again, determine the maximum height, so it's when v equals to 0. So we could have the equation that is v equals to u plus at maybe. Oh, not really. I think maximum height, so s v square, maybe v square equals to u square plus 2as. So v is 0, u is -8, 2, 10, and s. And so you can find s to be -3.2 meter. Okay, for part A. Part B is the time when it hits the sea. So I hope you can still learn from the example that we did. Let's just try to do it straight away. So when it go from the beginning and when it hit the sea, the s displacement is 35, u is -8, a is 10, and you want to find the time t. So the equation should be s equal to ut plus half at squared. Substitute -8 t half 10 t squared. So again, using the quadratic equation program in your calculator, a is 5, b is -8, c is -35. So you should find the answer to be 3.56, or apparently usually a negative number, 1.96, and then you will reject the answer. So you only have the positive 3.56 seconds as the final answer. That is for part B. Part C, calculate the velocity just before hitting the sea. So we would like to have v equals to u squared plus 2as. So v is the unknown, u is 8. Again, you can do it in a different way, because it is physics, right? And then s is 35. So using that would be 27.6 meter per second, and that will be part C. Part D, okay, maybe I'll do it here. Distance the stone covers. Oh, distance. Okay, so apparently this one you don't have to do like kinematics equation. You just have to think, because you already got the information that this portion is going to be 35, and then when it go up, it reached to the highest height, which is calculated in part A, 3.2, but then it come back down. So it is 3.2 go up, 3.2 go back to the same level, and then 35 going down to the sea. So you just have to add them up together. So say distance D will be 3.2 times 2 plus 35, and then you can calculate it to be D equals to 41.4 meter. Last part, part E. Average speed and average velocity. Okay, this is an interesting question. So apparently you have to distinguish speed and velocity. Speed is scalar, while velocity is vector, and they refer each of them. For speed, it refer to another scalar that is distance. For velocity, it refer to the vector that is displacement. So for average speed, so say I'll put down speed, I put a bar to represent average, and that would be the total distance. Total distance was 41.4. If I have more space, I would like to write down the words, but I'm trying to be more lazy here. So divide by the time, which has calculated to be 3.56. So using calculator, you can find 11.6 meter per second. For velocity, actually I could use V. Alright, so V bar is actually the total, not total, but just simply the displacement, which is 35, because we basically neglect whatever happened. We just care about the initial point and final point for that, divided by the time, which we find earlier. Using the calculator, we can find it's about 9.83 meter per second. So for sure that you should always find, logically, average velocity must be smaller than average speed, because for distance it's always longer than displacement, if you think like deeply, and so therefore velocity always must be smaller than the average speed. Okay, so here is the last question. He said there is a ball flown upward from the edge of the cliff with velocity. So normally I would like to draw diagram. So ball upward 20 meter per second u, and well, let's just try, how about let's just try upward as positive this time. Okay, and then it reached the bottom 6 seconds later, so we got t, we got u. Determine the height of the cliff. Okay, interesting. So apparently the height can be represented by s, which in our case will be negative. We can predict it's negative because our upward is positive. So we want to find s. We know t, we know u, we also know a is -10, because again upward is positive, meter per second squared. So using the equation that is again u equals to, sorry, s equals to ut plus half at squared, then you can find s, because u is 20, t is 6, plus half, -10, 6 square, and then just use your calculator. The answer you should find is -60 meter, and so apparently the length or the height is 60 meter. So maybe you can say then height is 60 meter simply. That is part A. Part B, calculate the speed when it hits the ground. Okay, I suppose there's no C, so it's simply ground below. So basically finding out V. So we can use V squared equals to U squared plus 2AS, I believe. V squared equals to 20. Upward is positive, so yeah. Plus 2 -10. S is -60. Okay, be careful, be very consistent with your direction. So after you calculate all these things, you can find V is 40 meter per second. And yeah, I think that's all. For the next part of the video, we will start to do something called the projectile motion.